Good day, everyone. My name is Rebecca Lilly for the International Association for Energy Economics. It gives me great pleasure to welcome you to today's webinar entitled Factors Affecting Renters' Electricity Use. We are grateful to our speaker, Dr. Rohan Best, for today's timely discussion, and note that this paper was recently published in the Energy Journal. First, a little bit about the International Association for Energy Economics. We are the largest association specializing in the field of energy economics and provide a forum for the exchange of ideas, experience, and issues amongst professionals interested in the field. The organization produces 2 professional journals, a newsletter, and holds conferences and virtual presentations, along with a host of other products and services that you can find at our website at www.iaee.org. If you're not already a member of the association, we welcome you to join. A few housekeeping matters in regard to today's webinar before I hand things over to our speaker. First, this webinar is being recorded for those who cannot participate in today's live event. If you have questions for our speaker, please click the Q&A button at the bottom of the Zoom window and type your question. We have allocated sufficient time at the end of the webinar to address your questions. And now, I would like to introduce you to our speaker, Dr. Rohan Best, Senior Lecturer in the Department of Economics at Macquarie University in Australia. Rohan, over to you.
Thanks, Rebecca, and thanks to the IAEE for the introduction and for the opportunity to present today. The discussion today is on the residential energy context, and in particular, I'll be focusing on the differences between renters' electricity use compared to homeowners' electricity use. The paper that I'm referring to today, as Rebecca mentioned, has been recently published in the Energy Journal, and here is a link for that paper for people who might be interested. This paper is based on some data from the US, which I will come to shortly. The co-authors on this paper, none of us are from the US, but we're all interested in the US as, very interesting context with excellent data. That's our background, and you can see my co-authors there, Paul and Shuhei. Before I go into the background and the details and the method, I'll just give the overlying theme for the presentation and the key results. And what we find is that there are large impacts of renting on electricity consumption, and somewhat larger than a lot of prior studies have found. Our results showed that renters use around 9% more electricity when controlling for a lot of variables such as location, housing characteristics, socio-demographic aspects, and some appliance quantities. I'll refer back to this issue of appliance quantities a number of times because this is an interesting area. We split appliance quantities into 2 types, and this is based on the data. One group is for appliance quantities that renters have less of, so when renters have fewer appliance quantities, or when renters are less likely to have an appliance type. This applies in most cases, but there's a few types of appliance where renters are actually more likely to have that appliance type, or renters might have a higher quantity of a few particular appliance types. I'll come back to that shortly. So this large 9% difference in electricity consumption between renters and non-renters on average can be explained through a number of channels. And because there's already a lot of excellent research on split incentives, we tried to go beyond split incentives and to look at multiple factors which are also responsible for the electricity consumption differences between renters and non-renters. So there's 4 factors there, or 4 groups of aspects. The first 2 are the split incentive types. For example, energy efficiency refers to the energy efficiency split incentives where landlords may not have an incentive to invest in efficient appliances, if this doesn't benefit them through the potential to charge higher rents. For the consumption split incentive as the second dash point referring to bill payment responsibilities, this is where renters may not have an incentive to lower their electricity consumption if someone else is paying for the bill, such as the landlord. But in addition to those two split incentive issues, we also look at a range of factors, including behavioural factors. One of these is higher television use, but this was just one out of a number. We also looked at many other things, such as different use of lighting, for example. And then the fourth main category that helps to explain why renters have much different electricity use is this issue that I've already referred to about renters have more of some types of appliance and they are more likely to have some types of electric appliance. Two examples are given there of electric space heaters and electric water heaters. Another one which I'll refer to is that renters are more likely to use electricity for cooking as opposed to substitutes such as natural gas. So now going back to start at the beginning, and I'll just give some brief background and some motivation for why we were interested to study this topic. And one key issue is that electricity is essential for modern households. It's a thing which most of us would struggle to live successfully without. And it's important that electricity consumption is at a reasonable level. If it's too low, then this can have adverse health impacts. This is particularly the case for people who may have to use energy consuming medical equipment. But it also is important for all of us. And if we think of the US context, heating is particularly important for the Northeast during winter, and cooling particularly important for Arizona and areas in the Southwest in the summer. But there's also problems if electricity consumption is too high, such as from inefficient appliances. And this can have substantial environmental impacts through greater pollution or greater contribution to adverse climate change. As you can imagine, this depends on the underlying energy mix that goes into producing the electricity. But the energy mix in all countries, including the US, often still includes some polluting energy types. We're also interested in this topic of renters' electricity use because renters are a large proportion of the population. For the US, it's around 30%, and this is quite similar to some other countries, such as Australia. And we're also interested in renters because they tend to have lower incomes on average. As you can imagine, it's not always the case. Some renters have high incomes, but on average, incomes tend to be lower. And as a broad statement, there tends to be a higher proportion of disadvantaged households that could benefit from changes, as I'll discuss in this presentation at the end, for policy solutions. So what we're trying to get to in this research is trying to understand, are there substantial differences in electricity use by renters compared to non-renters? And then to be more specific and to quantify the magnitude of these effects. Then we try to progress to understand what are the explanations for these differences, what are the channels which explain the differences. And then given the results, we try to put those results into a policy context and try to understand how could consumers or policymakers make changes that would be beneficial for society. So starting off with an initial snapshot of the data, and there's a couple of key points that I want to highlight here. One is that electricity use tends to increase as income increases. You can see that with the lighter colored non-renter bars, where as the income increases as you start at the top and move down the vertical axis, then you can see that the mean household electricity consumption tends to increase. In contrast, for the renters, this relationship is not as clear, and a couple of reasons for this are that renters are the minority of the sample, and I'll come back to what the sample is. It's the residential energy consumption survey, but renters are the minority. There's not as many of them, and particularly for the income brackets, the top 4 income brackets from about 80,000 annual household income and above, there's not that many renters in the survey. For this initial snapshot, we didn't put on confidence intervals or an indication of the variability around the mean. The reason being, this is just an initial snapshot of the data, and we do the more systematic analysis with the statistical significance in some regression approaches that I'll show you shortly. But the second main point I want to highlight on this slide is that the light bars are always showing higher electricity consumption than the dark bars for every income bracket. And you may notice that this is actually a contrast from the key finding, although the key finding was controlling for many variables. We find 9% higher electricity use by renters. Here, because we've only shown 2 variables, income and electricity consumption, you can understand that just controlling for income is not sufficient to understand the differences in renters' electricity use, which I'll show in some regression output. Part of the reason, which I've already mentioned, is that renters and non-renters differ substantially in terms of the efficiency of their appliances. So this figure shows many different types of energy efficient appliance, and we've also added in a couple of other things such as solar panels, which are probably not strictly energy efficiency, but which overlap a little bit. But the key idea is that non-renters are more likely to have all of these energy efficient and related appliance types. And some of the differences are quite substantial, particularly for Energy Star fridges. There's a major difference between the light coloured bar for non-renters and the much lower uptake for renters in the dark bar. So to be more systematic and to conduct our econometric approach, I'll discuss what we have done. And our approach is to use cross-sectional regressions. And the reason for this is that there is substantial variation across households, but much less variation over time. You can think of this in a housing context as one way, and we can think that some households, people will own their household, or they might move to another home which they own, and they might stay in this category for multiple decades. And likewise, some people might rent for multiple decades. It is true that some people will switch from one category to another, renting to owning, or vice versa, although these are relatively few and not that common. So our key frame is to consider a cross-sectional analysis because this matches with the key fundamental context of our research. A second reason is that the data are cross-sectional. So from a pragmatic standpoint, we're using a cross-sectional survey. This involves a trade-off because whilst cross-sectional surveys are excellent from the standpoint of having many variables in some cases and a lot of detail, obviously you don't have the time dimension there, so there can be a trade-off involved. We use ordinary least squares regressions for explaining electricity consumption, but for regressions which explain the uptake of energy efficient appliances, because that is a binary outcome, we also use some binary dependent models. We use a logit model in particular, although we also do show results in the paper with an ordinary least squares model, which is a linear probability model in this binary context. And a good thing about large surveys with many variables, you often get similar results either way. As mentioned, we use the 2015 US residential energy consumption survey. This has about 5,700 households. The main results which I will show are for about 5,000 households, because there are around 600 of the total sample which use imputed electricity values. It doesn't really make much difference at all to the final results. As you can imagine, 600 out of 5,700 is not that much, and it's reasonable also to have a lot of confidence in the imputed values anyway, because these were done by the US Energy Information Administration. But yeah, either way is giving a similar story. This survey is good in the sense that it is nationally representative, and it also has probability weights, which we produce results both with and without probability weights. Key challenges that are often addressed and often confronted include omitted variable bias for cross-sectional approaches. To address this, we use many explanatory variables, including locational controls, to capture some otherwise unobserved variation across locations. And for interested people, the paper has around 100 explanatory variables. So there's many explanatory variables, and these are just about all displayed in table A1 in the appendix. We didn't show some of the locational controls because there were so many variables. So hopefully this helps with addressing omitted variable bias, because we've controlled for so many things, and hopefully we've controlled for all of the important things. As you'll see, the proportion of variation is quite large with the high R-squared values. This also does lead to the possible additional concern that with so many variables, maybe there is a higher risk of multicollinearity, where there's correlation between these many explanatory variables. We address this by assessing and checking the variance inflation factors to make sure that they're not too high. But we also look at explanatory variables in groups. So we do what is sometimes referred to as hierarchical regression by progressively adding groups of explanatory variables, and we can see how the coefficients change as we add explanatory variables. So we can kind of see if collinearity is having an effect, and it's not having an effect because the coefficients tend to be consistent across the different regressions, except for the key variable of renting, which we can explain and which we expect to change because of the context that I'll go through. Another problem in econometric regressions can be reverse causation. A key variable here is electricity price. To get around this issue, we exclude electricity price from most estimations, but the results are quite similar either way. So it doesn't have much of an impact at all on most of the coefficients. There are some small changes to some coefficients, as you'll see. Another group of variables which might be affected by reverse causation is appliance purchases. For example, if electricity consumption is high, then people might be incentivized to purchase new and more efficient appliances to try to reduce their ongoing electricity bills. We address this by, in some results, dropping households from the analysis where they made a purchase of a major appliance within the previous 2 years, but results are similar either way. Another econometric challenge can be measurement error, and this can be particularly important for some variables, such as the designation of appliances as efficient, because this is done based on the Energy Star stickers, which in some cases people may have removed or may not be aware of. So this can be addressed by either having a simple variable, which is just yes or no for efficient appliances, but also there are more complicated approaches to also control for people who state that they don't know if their appliances are efficient or not. The econometric approach is shown here. So the initial approach tries to explain the natural log of electricity consumption for each household H. And our key interest is in this alpha coefficient in front of the binary renter variable. And we try to isolate this renter effect by also controlling for a range of other variables, including location variables, socioeconomic and related housing characteristics, this energy appliance quantity vector F, which focuses on the appliance quantities which are less prevalent for renters. So this is most types of appliance, as I mentioned. And also, as mentioned, the average electricity price we exclude from most estimations, but do put it in there to understand what a price elasticity of demand quantity could be. Just one point for this S variable for socioeconomic and related housing characteristics. In some of the slides, I'll show that as a single group, and in another result, I'll show that as split into two categories. After we had tried to quantify that alpha effect of the renter effect, how much different is renter electricity use, we then also add additional groups of explanatory variables to try to understand what explains the renter effect, because if the renter coefficient becomes insignificant when we include these other groups of variables, then that can tell us that the other groups of variables help to explain the channels of the renter effect. It explains what is underlying the difference between renters and non-renters. The main groups, as mentioned, that we add, that I'll discuss, are appliance types for which renters have more of. This is the electric space and water heaters and electric cooking. In addition, there'll be a group for energy efficient appliances, and this is based on both Energy Star appliances, and we also use the age of appliances based on the assumption that newer appliances tend to be more efficient. And we use this because for some appliance types, Energy Star appliances are not applicable or not reported. We also include behavioural variables such as television lighting use and also bill payment responsibility. So here are the results, and this is focusing on the renter coefficient. You can see in column 1 that there is a negative impact of being a renter on explaining log electricity consumption. And this is consistent with that first bar graph where renters had much lower electricity consumption than non-renters. This is still the case in column 2 when locational controls are included. But in column 3, when the house size and type are controlled for with a number of different variables, the renter coefficient is no longer negative and significant. It's insignificantly different to 0. In column 4, when you also include socioeconomic controls such as income, but many other variables as well, then the renter coefficient is now positive and statistically significant. And this is approximately a 6% difference between renters and non-renters. This difference is even higher at around 9% if you control for those appliance types that renters have less of, which is most appliance types. We also show the log electricity price. Well, we've controlled for that in column 6. The renter difference, or the renter effect, is about 8% instead of about 9%. You can see that the proportion of variation explained goes up substantially through looking at the bottom row of the R squared, increasing from less than 0.1 up to over 0.6. So now that we've tried to establish that the renter effect is large, now we try to understand what explains that renter effect. So this looks at the channels which explain the renter effect. The first column is just a repeat of the previous slide, and we've shown all the same controls from the previous slide, but we've just sort of grouped some of them, so we just have 4 rows instead of 5 in that top or that middle section, referring to controls for location, socioeconomic, and so forth. But the key for this slide is that we add the channels of effect. So column 2 adds one single channel. It adds the channel of some appliance types renters have more of. So this is the electric heating and for space heating, and for water heating, and for electric cooking. If you control for those 3 variables, then the renter coefficient appears to drop from about, well, it's from 0.077 to 0.046 in column 2. So the renter effect then looks like it's about 5% if you account for the fact that renters have more of some electric using appliances. So this explains part of the renter effect, but not all of it. If you look at column 3, you can also see that part of the renter effect is explained because the coefficient drops. But again, it's not fully explained because the coefficient is still statistically different to 0. And this third column is just controlling for appliance efficiency variables in addition to the control variables. It does not control for any of the other channels. Column 4 gives the same renter coefficient to 3 decimal places. And this is when including the channels of household behavior variables. So if you account for household behavior, then there is still some unexplained differences between renters and non-renters. And this is also the case in column 5 if you account for the channel that some households use natural gas and other households do not. Column 6 also still shows a difference between renters and non-renters through the positive and significant coefficient for renters in the top row, when you account for the bill payment responsibility. In contrast, if you look at column 7, and this is where all of the channels are included at once, then the renter coefficient is no longer statistically different to 0. That sort of gives the indication that it seems like we might have controlled for all of the channels and all of the variables which explain the renter coefficient. But the implication is that no single channel explains the renter coefficient. It's necessary to include multiple channels to be able to understand why renters' electricity use differs to non-renters' electricity use. The paper in the appendix tables show other key results, not just the renter coefficient. They also show expected socioeconomic effects such as higher electricity consumption being associated with higher income. also, if households have higher education levels, they are able to achieve lower electricity consumption, all else equal. Also, we find that more appliances lead to higher electricity consumption as expected. So this is just useful. One, first, to try to make sure that our results are reasonable, and second, to try to understand the quantities involved. So there's many quantities to look at in the paper for interested people. We also look at the effect of efficiency, and there's, for households which have efficient appliances, this leads to lower electricity consumption in the case of windows, light bulbs, and freezers. We also find expected behavioural effects. So if people watch TV more, there's more overall electricity consumption. Also, the expected effect of households paying their full bills leads to an incentive to lower electricity consumption. For the price elasticity of demand, which I mentioned, this is around minus 0.55, which is similar to other studies. In addition to having electricity as a dependent variable, we also looked at efficiency dependent variables or other types of energy, appliance, or behavior as dependent variables. And I'll go through these 5 types in the coming slides. The first group is these equipment types where renters have more of these. So we used the underlying data to understand that renters had a higher proportion of renters had these electric using appliances or equipment. And we also confirmed this with regression approaches, which also controlled for other socio-demographic and housing variables. So these results all control for other socio-demographic and housing variables as in previous results. And these results show odds ratios from a logit model. So we're looking at whether the coefficients are, or whether the odds ratios are statistically different to 1. And in each case here, they are. So renters are more likely to have electric space heating, electric water heating, and to use electricity for cooking. And these outcomes are true when controlling for many variables and statistically significantly different. We also looked at the uptake of energy efficient appliances. So you can remember back to the second bar chart. So this is essentially looking at the same thing as that, except that now we are controlling for many other socio-demographic and housing variables. And there are still major differences between renters and non-renters, and these are statistically different at the 1% level in each case. And again, we have shown the odds ratios. So we're looking at differences to 1. And because all of these odds ratios are less than 1, it's telling us that renters are less likely to have all of these types of energy efficient appliances or upgrades. So you can see that renters are less likely to have adequate installation and all of these types of energy star appliance or energy using equipment. We also looked at some other energy outcomes apart from energy efficient uptake. And this set of results starts off again with some binary variables. So the first 4 rows of numbers also show odds ratios. And you can see that renters are more likely to have the most used television on for 4 hours or more on a weekday. And this is true when controlling for many variables, many socio-demographic and economic variables, which are not shown here to say space because they don't fit on the slide because there's many, many variables, as I mentioned. We can also see that the odds ratios for other energy outcomes, which are not this behavioural variable for TV, these other energy outcomes are less than 1. So for a smart thermostat, this is less than 1. So this is telling us that renters are less likely to have a smart thermostat. Renters are less likely to pay all their electricity, all else equal when controlling for other variables. Down the bottom, we've also shown some outcomes which are not binary. So these are integer dependent variables. So we used ordinary least squares for these ones. And for the use of lighting, this did not differ between renters and non-renters in terms of statistical significance. So renters and non-renters are not statistically different in terms of their lighting use. And this was also the case for the frequency of clothes dryer use, although that one was closer to being significant because you can change around control sets for that dryer regression. And in some regressions, it does appear that renters are more likely renters used clothes dryers more times per week in some regressions, but not in the one that I've shown here. It was statistically insignificant. There's also a major difference in the solar variable, which I skipped over. So renters are less likely to have solar panels, as indicated by the odds ratio being less than 1. And this one was only statistically significant at the 10% level with the 1 star. This is partly because in 2015, there weren't that many households in the US who had solar panels, particularly in some of the locations. Because we used locational binary variables, there were some locations where nobody in the survey had solar panels. So this led to these households being dropped just in that solar regression. But there are a number of other papers in the Energy Journal which do look at solar uptake in more detail and which really focus on solar panel uptake. In the paper that I'm discussing today, solar panel uptake was just one regression out of many, many regressions, and it wasn't the focus at all. But these two papers here do focus on solar panel uptake, and I've given some details there in case anyone is interested. So given our results from the study, we found that no single channel could explain the large difference between renters and non-renters in terms of their electricity use. Our results showed that multiple channels were necessary to explain this difference. So therefore, from a policy context, it's also likely that multiple policy approaches would be needed to address the multiple channels which underlie the differences between renters and non-renters' electricity use. The paper is not really about comparing different policy approaches. It's more about quantifying the difference and then trying to explain the difference. But given that we've done those things of quantifying the difference and explaining the different channels, we then just sort of discussed briefly and raised the possibility of a whole range of different policy approaches. These can include greater use of household-specific metering, such that consumers can then be responsible for the payment of their own bill. This can be useful in addressing consumption split incentives so that the people who are doing the consumption also then have the incentive to reduce that consumption, given that they would pay for the bill. For the efficiency split incentive, there are a number of ways to deal with that. That could be addressed through minimum efficiency standards, which has been undertaken in a number of jurisdictions. And this is something, for example, in Australia, which is has been done in some states and is also part of ongoing discussions. Apart from efficiency standards, it's also possible to look at various financing means, such as cost sharing of appliance upgrades between renters and landlords. For example, renters could be charged slightly higher rental payments if landlords could introduce more efficient appliances. There are other means such as appliance leasing, or in trying to bring in third parties for financing energy upgrades, such as through securitization of revenue streams. And this has been something which has been done in the US, although it's for solar panels, although in some countries such as Australia, this is much less common. It's also possible to use subsidies for renters, and this is something which I'm not aware of being too common in terms of the US in terms of energy appliances, but it is something which has been introduced recently in Australia, where they have subsidies for solar panels, which can help renters to reduce their electricity consumption. A further approach for consideration might be greater information disclosure, so that people have a more detailed understanding of which appliances consume the most energy and how to change electricity use so as to minimize that electricity use. So that's all that I had intended to discuss in terms of the slides, but if there are any comments or questions, these could be also good to discuss further. So back to you, Rebecca.
Okay, I was going to wait a moment just to see if there were any questions that came across, but if not, IAEE would like to thank you, Dr. Rohan Best, for an outstanding webinar. This webinar will be available on IAEE's website for a future download. If you're not a member of IAEE, we encourage you to join by visiting www.iaee.org. We thank you for attending. And given that there's no other questions, we will officially close this webinar.